Bismillahir Rahmanir Rahim. Assalamu alaikum students. This is Hamza Noor, and in this particular video I'm going to solve the question number 8 of International A-Level Edexcel P3 January 2022 paper. So it says that a dose of antibiotics is given to a patient. The amount of the antibiotics X milligrams in the patient's bloodstream T hours after the dose was given is found to satisfy the equation log with the base 10 argument x, it is equals to 2.74 minus 0.079t. So the requirement of part A is to show that this equation can be written in the form x is equals to p multiplied by q raised to the power minus t, where p and q are constants to be found. Give the value of p correct to the nearest whole number and the value of q correct to two significant figures. So in part A, we have this equation log with the base 10 argument x, it is equals to 2.74 minus 0.079t. So here what we need to do, we need to make x the subject, and x is basically the argument of the log. So when x will be made the subject of the equation, so log will be removed and the base of the log, which is 10, it will become the base of the index form. So therefore we can say that x is equals to 10 raised to the power 2.74 minus 0.079t. So now in the next step, according to the laws of indices, I can rewrite this equation like this. X is equals to 10 raised to the power 2.74 multiplied by 10 raised to the power minus 0.079t. And now for the next step, as we know the fact that a raised to the power m times n, we can rewrite it like this. A raised to the power m is whole thing raised to the power n, or we can also say that a raised to the power n is whole thing raised to the power m. Okay, so according to this law, I can rewrite the equation like this. X is equals to 10 raised to the power 2.74 multiplied by 10 raised to the power 0.079, and this is raised to the power minus t. So now, as you already know the fact that we want our equation in this form, x is equals to p multiplied by q raised to the power minus t. So now if we make a comparison of the terms, we can say that p is basically equivalent to 10 raised to the power 2.74 and q is basically equivalent to 10 raised to the power 0.079. But we need p and q according to a certain requirement. We need to give p correct to the nearest whole number and the value of q correct to two significant figures. So first of all, we are going to evaluate the value of p, which is equals to 10 raised to the power 2.74. So we need to give the value of p correct to the nearest whole integer. So p is equals to 549.541, and correct to the nearest whole integer, this will be 550. And then we need to evaluate the value of q, which is equals to 10 raised to the power 0.079. Okay, and we need to give the value of q correct to two significant figures. So the value of q is basically 1.199, and correct to two significant figures, we can say that q is equals to 1.2. So therefore, according to the requirement, now we can say that x is equals to 550 multiplied by 1.2 raised to the power minus t, where p is equals to 550 and q is equals to 1.2. This is supposed to be our answer to part A. Alright, so now let's move on to part B. Part B says that with reference to the equation in part A, interpret the value of the constant p. So here we just need to interpret the value of the constant p, as we know that x is equals to p multiplied by q raised to the power minus t, where p is basically 550 and q is 1.2. So when t is basically equals to 0, so q raised to the power minus t will be equals to 1, because this will be q raised to the power minus 1 times 0. So this will be 1, and therefore x will be equals to p in this case. So x is equals to p when t is equals to 0. And t is equals to 0 basically means the initial moment when the model is started. So as we can see that the amount of antibiotics x milligrams in the patient's bloodstream t hours after the dose was given. So this means that initially the patient's bloodstream had 550 milligrams. Okay, so we just need to interpret this in words. So therefore we can say that P is the amount of antibiotic amount of antibiotic in milligrams, or you can say in mg, in the patient's blood stream when t is equals to 0, or you can say at the start. When t is equals to 0 also means at the start. So in this way you are going to interpret what the value of the constant p indicates. So this was the answer of part B. So now let's move on to part C. Before part C, we have some information that when a different dose of the antibiotic is given to another patient, the values of x and t satisfy the equation x is equals to 400 multiplied by 1.4 raised to the power minus t. So requirement of part C is to use calculus to find two significant figures the value of dx over dt when t is equals to 5. So I'm going to erase the working of part A and B so we can do the working for part C on the fresh page. All right. So here we have the equation x is equals to 400 multiplied by 1.4 raised to the power minus t. So as we know the fact that when y is equals to a raised to the power kx, so dy over dx is basically equals to, first we write a raised to the power kx as it is, and then multiplied by k ln a. So here we have the equation x is equals to 400 multiplied by 1.4 raised to the power minus t. So we need to find the dx over dt function, meaning we need to differentiate x with respect to t. Okay, so 400 is basically a constant term which is being multiplied with 1.4 raised to the power minus t. So 400 will come as it is over here. And then we need to differentiate 1.4 raised to the power minus t with respect to t. So first I'm going to write 1.4 raised to the power minus t as it is, and then it will be multiplied by minus ln 1.4. Okay, so far we have achieved this thing. So therefore we can say that dx over dt is equals to minus 400 multiplied by ln 1.4, and this whole thing is multiplied by 1.4 raised to the power minus t. So what we need to do, we need to find the value of dx over dt when t is equals to 5. All right, so dx over dt is equals to minus 400 multiplied by ln 1.4 multiplied by 1.4 raised to the power minus 5. And we need to give our answer correct to two significant figures. So minus 400 multiplied by ln 1.4, this is minus 134.5889, and this will be multiplied by 1.4 raised to the power minus 5. So therefore minus 134.5889 multiplied by 1.4 raised to the power minus 5, this is minus 25.0247, but we need to give our answer correct to two significant figures. Therefore, we are going to say that dx over dt is equals to minus 25, correct to two significant figures. This is supposed to be our answer to part C. So this was basically question number 8 of International A-Level Edexcel P3 January 2022 paper.